Hello. This session is OpenJDK Project Wakefield, the Wayland desktop for JDK on Linux. It's going to be a bit of a show here because we have three of us, so we're going to swap over. There's only two mics. We'll do our best. Very quick intro, and then I'll turn it over. So I'm Phil Race. I work at Oracle. I'm the lead for the client libraries on OpenJDK. Next to me is Aleksei Ushakov. He actually used to work in the Java 2D group at Sun a long time ago, but these days he works at JetBrains. And there's Niels de Graef, who's a product manager?
Product owner. But it's
whatever, at RedHat in the desktop group. And so he is going to do our first session. I'll hand it over to Neil.
Okay, that's good. Maybe I should.
You should.
I should. This is going to be very interesting to do. Yes, I did not sign up for some dancing, but it's fine. So first, quickly about the structure. We're first going to quickly explain what Wayland is, and then explain how OpenJDK then tries to work on it, and the whole Wakefield project. And then finally, we have an actual demo and some explanation by Aleksei. So quickly for Wayland, because we don't have that much time. So a bit closer? OK, that should be better. First of all, what is Wayland? What is X11, for example, that it tries to replace? So it's about displaying, so rendering things into let's say, a matrix of pixels, something we sometimes call a frame buffer. And you usually try to get that on a stream, but maybe also try to stream that somewhere over the internet. And why do we need something fancy around that? It's because once you have multiple applications trying to render something, you want to have something like some kind of decisions around, OK, do we put them next to each other, on top of each other, or that kind of thing? So basically window management or tiling or whatever you want. And that's where a display server comes in, and you talk a display protocol between the apps and a display server. And it's usually also very related to input management because, you know, if you type in something you want to go to your browser, for example, and you don't want to type your browser in some keylogger application or something. So quickly about X11, which is, let's say, the old thing. So X11, starting from the right, so we have the X11 Server, which you start up normally using something like startx, which is going to listen to a socket, usually based on a display name, usually something like 0. And then each of your applications, I mean, imagine those two top applications being your browser or your file manager, and then they will actually say, they will also connect to that socket. Sometimes if you have to do that display equals variable for the environment, and that's which kind of socket it will try to listen to, so it will define the server. Then you're going to say something like, OK, now please, X11 Server, can you create me a new window? So X create window or something with this window, with this width and height. And then you can do your fancy things that you normally would expect to be able to do from a window manager. Now, that whole logic of should we be doing tiling or should we be doing overlapping windows and so on, that's usually what another X11 client, which is then usually the window manager, comes in. And that actually helps in setting all the logic, let's say. So that's how the usual thing in X11 goes. Now, X11, very oversimplified. X11 is old. It's from the 80s. Now, being old is not necessarily a problem, but it is older than, for example, Java and Linux. But one of the things is that it made a lot of assumptions that don't necessarily hold anymore and that are baked into the core protocol. For example, it talks about a root window, which once you have multiple monitors, you can still try to have like one big frame buffer that spans all of those monitors, but if you have multiple DPI, you get into trouble. Once you have GPUs get complexer and complexer, there's overlay planes, and you want to do fancy stuff with that for performance reasons and battery reasons. There's security. X11 allows you to screen share anything and do input sniffing and snooping and spoofing without any kind of consent of notification. There's a dev room about Linux on mobile. I do not want a device that actually could do all of that with my private data. And there's also new UX paradigms like HDR, tiling, window managers, and so on that actually be a bit harder, especially HDR. It's very hard to do, for example, in X11. So at some point, people got together. They created a new display protocol, which is then Wayland. So it's very minimal, but like really, really minimal. It really tries to make sure it does not fall into the trap of making assumptions again. It goes to just say, OK, we have clients that want to send something rendered to a server, a compositor, let's say. And then we can then extend things over. So it doesn't even have a concept of top-level windows, for example. You actually need an extension for that. It's called the XDG shell, if you ever want to look it up. It's very fancy. And some things you just don't want to have that in the display protocol anymore. For example, screen sharing is also related to videos. So we said, OK, let's try to put it out of the core protocol and something with portals. But I will explain what portals are later. So what does a typical Wayland session look like? Is again, we start from the right. So we have the Wayland compositor. So which you start, that's going to be, for example, with GNOME, it's going to be GNOME Shell. With KDE, it will be Quinn. With Sway, it will be something else. And then we will, you will start a Wayland socket, which you can, again, listen to. You will talk to Wayland protocol. And a Wayland client will say, OK, please create me a service. And then using that extension, for example, the protocol extension using XDG Shell, you will then have something where you can say, I want to create a top-level window, and I want to do it this size. You can do positioning in Wayland, always fun. There's a lot of reasons for that. And, for example, another Wayland client can be X-Wayland, which is its own X11 server. So actually, inside your Wayland session, let's say, you can actually also then create multiple X11 clients, which will talk the whole X11 protocol and X-Wayland to the translation to Wayland itself in the best way possible. And I did lie a little bit that this is not, or I did say that there's not everything yet. So there are some things that we don't want to put into a display protocol anymore. We want to do that in the portals. So that's something that's new with Flatpak and snaps and all these containerization fancy methods. We want to make sure that there's some kind of permission thing, let's say, that allows you, for example, I want to do screen sharing. Let the user choose if that's OK or not. And then the dbus interface within a Flatpak, you can access that. And then, for example, go to PyPire and other components which do not necessarily need to live in the compositor. You will go to those, and then we can go to the next step, which is how portals can be maybe implemented, or how these can be used from within Wakefield. And I think that's going to be the part where Philip is going to come in.
All right. Okay. So, Niels described what Wayland is, and today what we now have is a project to be able to support that Wayland compositing desktop from OpenJDK. And what's it all about, really? Well, JDK is clearly a platform. It's not just an application, and it abstracts away that underlying platform, so we're not going to be exposing anything about Wayland. Today on Linux, it happens to be an X11 client. It's basically an X application at a crude level. But to be able to support that Wayland desktop, we need to make some changes in JDK. Some of the policies that Wayland has that Niels touched on around security and things like that mean that the things that just are supposed to work in JDK won't work, even if we're trying to be that going via that X-Wayland client that Niels showed on his diagram, right? Which is what we call X compatibility mode. So that's the Wayland's compatibility mode for X11 applications. And although we don't even work in that today, even if we start to work in that, is that really the long-term solution that we want? What we really would like is to maybe be a full-on Wayland-native client. So OpenJDK Project Wakefield, there's a URL there, is started a couple of years ago. And there are people from RedHat, JetBrains, and Oracle who are working on this. We have a repo, the standard in the standard format for OpenJDK project repos. And what are our goals? Well, first off, we're going to try to support that compatibility mode properly. So we'll have a fully conformant JDK, and everything works as well as it can do, as well as it should do on the Wayland, when you're running on a Wayland desktop, but we'll be talking the X11 protocol. We don't talk about it here, but most people will see that these days if you log into a Linux desktop, and if you pay enough attention, there's an opportunity to switch between purex.org and the Wayland desktop, which supports that compatibility mode. And right now, JDK only supports the Xorg. So the longer-term goal, as I just touched on, is that we want to be able to support native Wayland. So the X11 compatibility mode is some such things that I'm going to touch on, but the much bigger thing is that native Wayland port. And there's a list here I won't read out of the different kinds of things that we need to deal with. in making all of this work. And some of what we need to do for the native Wayland port is really just starting to emerge in the latest versions of GNOME. So it's not, this work is not intended for some, older versions of Linux. This is something that you'll want to or have to use on upcoming versions of Linux. And yeah, the policies of security that Wayland enforces, I think is the right word, are going to be some of the drivers for the things that we need to change. For example, the issues include, one of the most important things is we have an API that lets you capture screen pixels, and capturing the screen is, Niels touched on, is something that Wayland very early on, I think, and is very clear about, doesn't like people to be able to do for privacy reasons. But AWT has expected to be able to do that forever. We expect to be able to do things for like move the mouse, grab the pointer. We want to put our windows where we want to put our windows. Wayland will say, no, that's kind of our job. And you can't actually find out where windows are on the screen. Also, in the X-Wayland compositing, in the X-Wayland mode, there's the high DPI support is not complete. So in some of those things that I described above sound like the things that you'd only need maybe for a test framework, but these are actually part of our standard APIs, and not many applications use them, but we have to be able to support it. And there's a bunch of bug level fixes that we've found we need to do as well. And we actually, as the project went on, we actually found some bugs that were on the Wayland side as well. And there's a whole bunch of, all of these things are described in detail at that URL, which obviously I'm not going to read out for you. So where are we now? JDK 21 pretty much did all of the work. We got the spec changes in that we needed. And there is a complete new implementation of the robot screen capture that was done almost entirely, well, actually entirely by Alexander Zagintsev. It's using the screencast portal and Pipewire. The first time somebody tries to do a screen capture, there's a manual process saying, yes, that's fine, and then after that it's okay forever in theory. And there are some follow-up fixes going into JDK 22. We basically, if you have a desktop with GNOME 42, we should be good. And that will probably mean that vendors will be able to officially support running on the Wayland desktop in this compatibility mode with 22, which should ship in a month. And that's when we shift real focus to the pure Wayland toolkit. But there's, what's involved a bit more about that. Complete new toolkit, spans all of AWT in the window management and the rendering side. So all of these things here, creating windows, configuring windows, the management of everything, integration with the desktop, how you render to the surface. We can't use X11, OpenGL, XGL really, or Xrender, and X11 and Xrender is the default way we do everything on Linux today. Desktop integration, all of these different things I'm listing here need to be redone. When I was trying to describe it to somebody who's sort of more of a VM person, it's like, well, we need a new JIT and we need a new GC. And so that's the kind of scope of the work. So how would you do this? Well, I mean, a lot of GTK4 makes it fairly easy for a lot of applications to just port over because it deals with all of that, hides it from you, and then Wayland. One of the things it doesn't have a window manager, so it's client-side decoration. It's all client-side. And GTK would do that for you, and everything I think there, it sounds like it'd be easy to get a lot of things up and running, but it brings in a lot of baggage. If you do an LDD or something on a running GTK4 process, you'll be paging through it for a while. But really, one of the problems was it's just really hard to get the level of management of when you render to the surface in the way that we need to with GTK4. There's more work with using the low-level lib Wayland, which is basically the equivalent of lib X11. But we've generally, when we've tried to do something with in the JDK, like the last example was we were doing a pipeline for Mac OS for their new rendering engine, and they have a higher level toolkit that's intended for applications, but we needed to use the lower level one, and it just sort of works out that way, it seems, every time. But anyway, there's some new challenges that Wayland brings, that native Wayland brings, that aren't necessarily there, that aren't there in the X compatibility mode. We need a new library, lib EI or A, however people pronounce it. That's just prototyping in GNOME 45. Well, the API, I believe, is final, but I think it's the first time it's been out there. That inability to lay out windows that I touched on, it has some oddities like splash screens come up in the top left-hand corner of the screen, that's not great from my perspective. So there is already a toolkit in process, and Aleksei is actually going to be showing you that right now, and it's called WL Toolkit. So hand over to Aleksei.
Okay. We use a separate thread for event handling in our prototype called WL Toolkit. And actual handlers of Wayland events are dispatched on event dispatch thread. On Wayland, rendering happens on client side. The client need to notify the compositor about the region that should be updated. We need to have complete frame content and then submit it to the Wayland. That's required some changes in AWT and Swing code to make sure that all the content is ready for submitting. Also, we use software rendering for our toolkit. Actually, software rendering was the only option in early ages of Java platform for Swing applications. But since then, the situation has changed, and now Java platform provides hardware acceleration for all major desktop platforms. Surprisingly, in current WL Toolkit implementation, we have sometimes better performance than in X Toolkit in X11 compatibility mode. So, for example, if you know Swing Mark benchmark, it shows about 40% better performance than in X Toolkit. So it's quite enough for desktop applications, so we can use it now. However, there are some areas where we still have lower performance. For example, in current implementation, we have about 3 times worse performance comparing with the hardware-accelerated X Toolkit. So, of course, modern desktop applications need rich text capabilities, including our IDEs. So we are going to work on this and improve the performance of font rendering. Current plan is to use Vulkan as a hardware acceleration on with our WL Toolkit. And let's see our demos. So let's try to run them. It's quite an expected resolution here. Here you can see a special aw.toolkit.name property. It's standard property that set to WL toolkit to enable this toolkit for us. And that's run, swing set. Oh yeah, it looks like it fit the screen. Okay. You may notice that here we have unusual controls. Actually, Phil mentioned it. It's because Wayland in this core part doesn't provide client-side decorations. So these controls were rendered by ours, so in WL toolkit. Okay, and let's see how it works actually. So here is frames. Buttons. So we have some animated curve here, some combo boxes, dialogues. Okay, rich text capabilities, and yeah, some checkboxes working, some more dialogues here. So progress bar demo, scrollable image here in scroll pane, and sliders. Yeah, here we have split pane, debit pane with some animated images here, tables. Yeah, they work quite well, and tooltips. Yeah, and tree with expanded nodes. So as you can see, all the controls properly rendered here. And then I would like to show one more standard demo. These demos bundled with the platform for many years to show Swing UI framework capabilities. It's a Java 2D demo. It shows some advanced graphics. So we can see here curve rendering. Actually, it's not full speed, so we can reduce the delay and see how it works. Actually, quite well. Yeah. So we have many different things here. Some clipping, color conversions, compositing rules, font rendering, image ops, so it's some conversions for images, some stroking capabilities. Here's a mixed demo with different primitives, paint modes we have also here, path rendering, and transformations. So, as you can see, performance is quite acceptable. Now we'll try, because of the resolution, to launch a real-world application, community version of IntelliJ IDEA. Yeah, probably it would be. Yeah. Wow. Yes, it works. Yeah. And here we also see that we use the same property, awtoolkit.name, that in special property file that we use for IDEs. Yeah, here we can see actual Wayland implementation here. So it's a constructor. It's quite difficult to see something. And here is the separate thread that I mentioned that handles Wayland events. Okay, that's it. Thanks for listening. Any questions if we have time?
We have a minute. So any questions?
So you showed the like IntelliJ working, and it looks very good. So what is missing?
So what is missing for I'm repeating the question. You showed IntelliJ working, so what is missing?
Evils in details. We have picky users, and there are some stuff that in some corner cases that it's not working well, but it's generally workable. So we have some users who gives us feedback about the quality. So yeah, but we still need to polish it.
Yeah, that if it wasn't completely clear, right, you can try this for yourself. The the project that I actually didn't you have a slide showing the the branch? So you just can check out that that branch from the Wakefield repository and build it yourself and try it.
Yep.
Yes, over there.
Does it work with JavaFX?
Does it work with JavaFX? No, this is at this point, this is implementing within JDK. JavaFX is like a separate toolkit entirely, and we have to repeat this exercise for that, unfortunately. Yes, over there.
So did you feedback back bug fixes back to Wayland? Yes, how was that?
Sorry, feedback?
Did you fix bugs in Wayland?
Did we fix bugs in Wayland? No, we reported them to via our friends at RedHat. So we've had some calls, and some of the developers, a couple of the developers who kind of work on the desktop and even on Wayland directly, there and will say, yeah, file a bug here, or yeah, I think I know what it is, and yes, and so we've reported bugs and they've been fixed. Yes. Yes.
Any plans to support fractional scaling?
Any plans to support fractional scaling? My recollection is that Wayland itself fundamentally decided not to support fractional scaling.
There's an extension. There's a
Oh, of course, there's an extension.
There's a So yeah, there's a protocol extension to do fractional scaling, and if the WL Toolkit wants to implement that, it can do that normally. But it should work. It should definitely already with the native Wayland mode. It should already be better than the whole blurriness you sometimes get in X-compatibility mode. But yeah.
Yeah, the one thing about that, though, is just generally, I mean, with fractional scaling, we don't have to deal with fractional scaling on Mac because that's always multiple. With the Windows look and feel, we are still sorting out bugs, trying to make that work. So we would undoubtedly find a whole bunch of new bugs with the GTK look and feel when we started doing that. So it's not just a simple matter of saying, oh, yes, there'll be a mess to be sorted out that's separate from the Wayland project. I think we're probably out of time. Yep.